Let us discuss today fluctuation of energy and speed. Fluctuation of energy will be very much required while solving various problems related to flywheel. গতিকে এইখিনি বস্তু important আৰু then we'll study coefficient of fluctuation energy, coefficient of fluctuation of speed. এইকেইটা important বস্তু হয় problem solve কৰোঁতে we will be requiring them. So first of all, for fluctuation of energy, in the figure we have been given a figure of turning moment diagram of a multi-cylinder engine. So this is a turning moment diagram of a multi-cylinder engine. Now you can see turning moment diagram is a torque versus crank angle. So here you can see various energy loops, positive energy loop, negative energy loop. You can see the loops above the mean resisting torque is considered positive, and the loops below the mean resisting torque are generally negative. Now let us see. Figure represents the turning moment diagram of a multi-cylinder engine. AE is the mean resisting torque line, and let the area of energy loops between crank rotation A to B, B to C, C to D, and D to E are A1, A2, A3, and A4 respectively. Let us consider the areas as small a1, small a2, small a3, small a4. These areas up to A to B, we are considering it as small a1, B to C, this loop, small a2, C to D, area is considered as small a3, D to E, area is considered as A4. Area of the energy loop below the mean resisting torque line is taken with negative sign, and above the mean resisting torque line with positive sign. The variation of energy above and below the mean resisting torque line is called fluctuation of energy. So you can see there is fluctuation of energy. Now how will you determine the fluctuation of energy? Determining part is very important. Fluctuation of energy may be determined by the turning moment diagram for one complete cycle of operation. Let the energy at point A, let us consider at energy initially at the point A, the energy is capital U. Energy at point B will be, let us say, U plus A1, because this is positive, this loop is positive, we are writing it as capital U plus A1. Energy at point C, that will be U plus A1 minus A2, total energy. So at point C, the energy, total energy will be capital U plus energy from A to B, that is small a1 represented by A1 area, B to C, that is negative loop, so minus A2. Similarly at point D, it will be U plus A1 minus A2 plus A3. Energy at point E, U plus A1 minus A2 plus A3 minus A4. The energy of flywheel at point A should be equal to energy at point E. So it is a cyclic order. The whole operation is working in a cycle. So energy at point A must be equal to energy at point E. This is the important condition. Out of these points, capital A, capital B, capital C, and capital D, and capital E, there will be one point where the energy is maximum. Let us say at some point out of these 5 points, there will be at some point the energy will be maximum, and at some point energy will be minimum. Corresponding to this maximum and minimum energy, the fly will be having maximum speed and minimum speed. Difference between this maximum and minimum energy is called maximum fluctuation of energy. So it is represented by capital EF. EF is maximum energy minus minimum energy. Similarly, difference between maximum speed and minimum speed is known as maximum fluctuation of speed. Then we have to study coefficient of fluctuation of energy. Coefficient of fluctuation of energy is the ratio of maximum fluctuation of energy to work done per cycle. So it is represented by UF, maximum fluctuation of energy in this cycle, then divided by work done per cycle, how much work has been done in a cycle, particular cycle. Then coefficient of fluctuation of speed, this is represented by CF. It is the ratio between maximum fluctuation of speed to mean speed, and it is called coefficient of fluctuation of speed. It is represented by CF. CF is n1 minus n2 divided by n. N1 is maximum speed, suppose n2 is minimum speed, capital N is mean speed. So maximum fluctuation speed is given by n1 minus n2. Mean speed will be given by n1 plus n2 divided by 2. So ultimately it will be the expression will be 2 into omega 1 minus omega 2 divided by omega 1 plus omega 2. Reciprocal of coefficient of fluctuation of speed is known as coefficient of steadiness, and it is denoted by small m, 1 divided by CF. Next we'll discuss energy stored in a flywheel. Thank you.